Hi all, myself Professor Bhagyashree Lachwani from Ahmedabad Institute of Technology. In this lecture, we will cover subject TOC, that is Theory of Computation. In that, we will cover two topics, that is functions and relations. First, we will go through relations. Now, relations is basically are having a three type of properties. These properties are reflexive, symmetric, and transitivity. Now, what are these three properties? Reflexive is basically a property in that you have to consider one case, that is, just take an example, set A. So every element of set is reflect, that means is related with itself. Just take an example, here we have already enlisted set A, we are taking an element. Just take an example, x, small x we are taking. So x, capital R x, that means it is depicted as x is related with x. For every element in the set, it is related with itself. Second property of the relation is symmetric. In the symmetric, we have to take two elements. Just take an example, we are having a set A and two elements A and B, that are the small. Always try to give a relation, that is the function name or set name as the capital letters and elements belonging to the set as the small letters. So just small a and small b are the two elements of set A. Capital A is a set name. So in the symmetric, we have to depict like a way A is related to B. If one element is related to another, then in the symmetry you have to compulsory create a mirror image. That means compulsory B should be related with A, then only you can say it is a symmetric property satisfied. The third property is transitive property. In the transitive, you have to take minimum three elements. So where we are taking the three elements A, B and C, and first two conditions we have to satisfy. Suppose A is related with B and B is related with C, then from the transitivity property, compulsory A should be related with C, then only we can say this relation is satisfying the transitive property. Now the question is, when you can say your relation is an equivalence relation. So equivalence relation, you can say if and only if your relation is reflexive, symmetric and transitivity. That means if even a single property among reflexive, symmetric or transitivity, none, if a single property is not satisfied, then your relation is not an equivalence relation. That means if and only if your relation is reflexive, symmetric and transitive, then you can say your relation is an equivalence relation. Now we will just take here one example. One set is given to you. Set is given in the form of 1 2 3 4 5 6. Okay, set A is given and one relation is given to you. Just see here in this example, suppose R set is given to you 1 1 2 2 3 3 4 4 5 5 6 6 2 1 3 1 4 1 5 1 6 1 4 2 6 2 and 6 3, and we have to check for two properties. Just take an example, reflexive and symmetric, whether these two properties are satisfied or not. So we will check one by one. Just take an example, our original set A is having an elements 1 2 3 4 5 6. So just check in the set R, 1 1 is present, 2 2 is present, 3 3 is present, 4 4 is present, 5 5 is present, 6 6 is present. That means each and every element of set A is related with itself in the set R. That means you can say the set A, or here the relation R is a reflexive, because each and every element is having a mirror image, that means of itself in the given set. Now we will check for the second property, that is the symmetric property. So in the symmetric, what was the condition? Each and every element should have, must compulsory have a mirror image in that. So we will observe one by one. Suppose take an example, we are taking the pair 2 1. If you will see in the relation R, 1 2 pair is not here. That means if 2 1 is here, you must have compulsory 1 2 pair. So from this we can say if A is related to A is related to B, that means 2 1 pair is there. That means compulsory 1 2 pair must be there. But in the R, 1 2 pair is not there. That means it is not the symmetry. So if it is not symmetry, we can say this relation is also not an equivalence relation. Hope this is clear to you now. Now we move on to the second topic of this lecture, that is the functions. Basically in the function, we are having the two sets given, set A and set B, and we have to anyhow see the relation what is between two given sets. Just take an example, function is indicated with f. Here the notation is given f colon A belongs to B. That means f is a function we are having the two sets given, A and B. So whatever the elements in the set A are given, that is termed as a domain. Whatever the elements on the set B is given, that is termed as a codomain. We will apply one set here on the elements of A, that means it is given as fx. So fx is also called the image of x under the function. That means, just take an example, fx equals to x square. Now in the value of x square, x you have to take the elements from set A. Whatever will be the answer of x square, that all elements will belongs to set B, that is the another set. Okay, now here two types of functions will be there, one-to-one function and on-to function. One-to-one is also another name of the one-to-one is injective function, and on-to function, the another name of the on-to function is given as subjective. So and it may happen that sometimes the question is asked like a way, whether check whether the function is injective or not. That means you have to automatically understood they are asking it is one-to-one or not. Same way, if it is asked like a subjective, that means if they are asking check whether the function is onto or not, and if your function is one to one and onto both, that means your function is injective and subjective both, at that time you have to say your function is in bijective. Bijective means that function is satisfying both the properties one to one and onto. Now what is actually one to one and onto? The one to one is, just take an example, in the element A, whatever image you are taking from the domain, there will be exactly one image in the set B. That means one element have a relation with the one, that is termed as an one to one. And what is onto? That means every element in B is an image of some element in A. That means in another words we can say range is equals to codomain. That means whatever elements in the B are present, they are answer of one of the elements of the set A. There should not be even a single element in the B that is not the answer of function A after applying the function. So that is termed as an onto function. Just take an example here, f belongs to R plus 2R. See here the domain and codomain are very important. Domain is given as R plus, that means we have to take the elements of R but in the positive manner only, we cannot say the negative values. So R plus 2R, and fx is given as x square. We have to check whether it is one to one and onto. So by one we will check whether it is one to one and onto. First we will just take an example, x value as the 2. Okay, so R plus 2R, that means first we will take R plus f2, the value will be 4, R plus f3, the value will be 6. Like a way, if we will take one by one, that means it is one to one because we have to only take the R plus value. Now we will take for the onto. If you will see R plus, that means if you will see the codomain is here R. In the codomain the positive values are also there, the negative values are also there. That means both the values will be there, but negative values can never be an image of any square of any of the number. That means it is not an onto function. Okay, so like a way you have to check whether your function is one to one or onto or both, and from this you can see if your range is equals to codomain, that means your function is an onto. Okay, hope this is clear to you. Thank you for watching the